We now look at section 2.4, which is about exact equations. So when will a differential equation be exact? That is something we will learn today. Previously, we saw how to use the method of separating the functions or separating the variables, so solving equations which are separable. And then in 2.3 we saw how to use the integrating factor when the equation is given as equation is given in the form that we call linear and first order differential equation. Now if we have an equation which is not linear and which is also not separable, then how do we solve it? So let's look at this method. And so maybe it is exact. Okay, so how do we figure out if an equation is exact or not, and how do we solve an exact equation? So we suppose that we are given an equation of this type. You can see this is not exact, the linear first order, because we can separate the sum of the x y terms. But if you notice the dy by dx, a function of x and y is being multiplied, so it is not a linear first order differential equation. Okay, so now we are saying, suppose that we know that there exists a function something like that. So when we do the partial derivative of this function with respect to x, which the notation for the partial derivative are given here. So how do we differentiate? If you recall from Calc 2, I believe, or Calc 3, sorry, that is partial differentiation, that we consider the other variable to be constant. So when I am differentiating this f of x, y with respect to x, then y will be treated as a constant. So the first term is y squared, so we will treat it as a constant. So constant means the derivative is 0. So now we have the next term is x squared plus 1 times y. So now this will be treated as a product. So x squared plus 1 times y. So when I differentiate, I will, we can apply product rule, or we can just think that y is a constant. So we basically just take the derivative of this quantity. So we get 2x. So the derivative of x squared plus 1 is 2x times y. And then minus, now this is completely a function of x, so the derivative is 9x squared. So we end up getting 2xy minus 9x squared. Now let's find the partial derivative of this function with respect to y. Now we will treat the x terms as constant, or any functions of x as constants. So when I start differentiating with respect to y, the first term is 2y squared, so I get 2y. Now x squared plus 1 will be considered as constant, so only the y will be differentiated. The derivative of y with respect to y is 1, so we end up getting just x squared plus 1. And then the last term is completely of x, so no y there, so answer will be 0. Now we differentiate we simply get the f of y of x is like that. Okay, so now note, compare now this thing with the given equation. If you notice here, this over here is f of x, f sub x, a partial derivative of f with respect to x, and the quantity which is being multiplied with dy here, this is f sub y. So we can write our differential equation as f sub x plus f sub y, means partial derivative of f with respect to x plus partial derivative of y with respect to y, and dy by dx equal to 0. So now recall from Calc 3 that if f is a multivariable function, f of xy, then dy dx of f of xy will be the partial derivative of f with respect to x plus the partial derivative of y with respect to of f with respect to y times dy by dx. So now when we integrate, so if I can move the dx, we can distribute or multiply by dx throughout. So I am left with d of f xy is equal to f sub x dx plus f sub y dy. So when we integrate, d of f is equal to integral f sub x dx plus f sub y dy. So we get a function of x and y, but then we say this is equal to a constant. So the general solution for the given DE is actually the level curve f of xy is equal to c. So now this we call it the differential because it involves the differential here dx and dy. So m, so we are picking some function name m and n. So there are two functions m and n, both of x and y, and both would not be the same. They will be different functions. So we say that this differential is said to be exact if there is a function f of x, y such that the partial derivative of f with respect to x is equal to m and the partial derivative of f with respect to y is m. And then we can write something like that. The exact equation is the derivative of a level curve, or the exact equation gives the slope of lines that are tangent to the level curves. Just a quick review of how to find the partial fractions and or how to find the dy by dx implicitly. So if we are given the f of x y equal to x squared cosine of y plus e to the 2x, and I want to find this, then this quantity, which can also be written as f sub x, will be equal to, so wherever I have a function of y, I will consider it as a constant, and if it is just y alone, then the derivative will be 0, but if it is coming with a function of x, we just differentiate the function of x and the function of y just stays as it is, like a constant. So the first term is x squared cosine of y, so cosine of y will be treated as a constant. We just differentiate x squared, which is 2x, so I get 2x excuse me, times cosine of y plus next term is y, so derivative of y with respect to x will be now 0 because we treat y as constant, and then plus e to the 2x, so the derivative is 2 times e to the 2x. What will be the partial derivative with respect to y? Okay, the first term, now we will treat the x squared as the constant and the cosine y will be differentiated. So we will keep the x squared as it is. Cosine y, the derivative is negative sine y, so I will put the negative here, sine y plus y, so the derivative of y will be 1 and then the derivative of e to the 2x will be 0. So this is f sub y. So let me write it a little bit clearly. Okay. Now let us say we are given this, so we have to find dy by dx. So how do I find the dy by dx? If you recall from Calc 3, I believe, so you would put this, if you recall, there was a formula that, let me check that. So you had a formula that dy by dx will be equal to well, actually we can use this. So fx plus fy dy by dx. So the partial derivative with respect to x is here. So I have 2x. Actually from here let's simplify this first. So this gives me f sub y dy by dx is equal to negative partial derivative with respect to x, which implies the dy by dx will be equal to negative partial derivative of f with respect to x divided by partial derivative of f with respect to y, so that in our case dy by dx will be equal to negative this quantity whole thing divided by the f of y. So let me write it like 1 minus x square sine of y. Sometimes we can simplify it by when we have a negative sign here hanging in the front, we can distribute the negative, but you will see that the negative will come with both of them. So what we do, we can factor out the one negative sign from the bottom and write it as, so top remains the same, but at the bottom I can factor out the negative sign. So inside I get negative 1 plus x square sine y. So then now this negative and negative cancel out. The top is 2x cosine y plus 2 times e to the 2x, and the bottom now becomes x square sine of y minus 1. Okay, now integration of a multivariable function. So when you have a function of f of x and y, and you are integrating with respect to x, and this is why these differentials are important, because if we don't write the differential, then we don't know with respect to what variable we are integrating. So f of x y will be that we are going to integrate this function with respect to x. So again, we will treat the y on the function of y as functions of y as constant. So we get x cube over 3, part A, x cube over 3 plus, so we are integrating with respect to x, so y is treated as a constant. So I have 3x squared over 2y. And then plus, now y cube is constant, and integration will be just x times y cube. So now plus c, normally we write c because previously we were doing the integral, finding the integral of function of one variable. So the constant was a number, but here we can have a function of y. So I will write plus g of y. Instead of c, now we have function of y. And the reason is because when we differentiate with respect to x, the g of y will be 0. Now integrating with respect to y, now we will treat x as constant. So this is our function. Okay, so first term will be x squared y plus 3x y squared over 2. So let me put the 2 in front here. So 3 over 2x y squared, and then plus y to the 4 over 4 plus h of x. So now we give a new name and it will be a function of x. Okay, rest I will do in next video.